Each leaf is made of thin metal sheet. The leaf length is 3 feet and the breadth is 2 feet, folded exactly in the middle to form a 1 feet height. I don't believe in aerodynamics all the time, right? There is also something called wind power, where the molecules of wind will impinge on any obstacle and then move it forward, and I use that aspect of that. You don't compare this with any aerodynamic foil. This is not aerodynamic. This is like a butterfly's wings. So butterfly is not aerodynamic, but it flies successfully. In a similar manner, imagine that molecules of wind will impinge on these leaves, that the molecules which are trapped will have to escape, and it will get concentrated and then have to be escaping through that 3 feet tip. So that will give a kind of push to this leaf. On the other hand, the approaching leaf, whose backside is also bent, that the air which falls on that will be diverted into the crevice and then onto the working leaf. So this way the drag is minimized in this design, number one. 6 leaves I have taken because each leaf is opposite to each other. So it's very easy for anybody to assemble it on the field without any technician's help. Wind from any direction can be captured in this, and it's more stable. Initially I started with 3 leaves, then 4 leaves, 5 leaves, and 6 is the optimum that can be achieved. More than 6 also can be possible, but then the weight will be increasing. Weight of this rotor is also required, that I cannot construct it entirely through an aluminum foil. The reason is that the weight of the rotor will act like a flywheel to store the energy and then provide the energy during erratic movements or erratic wind flow. Especially since I am using a piston pump, therefore the power stroke and the idle stroke, the suction stroke, etc. will be uneven, and therefore require an evening out of forces, and hence some amount of flywheel kind of mechanism is required, which is now provided by the rotor itself. Let us see the mechanism. The axis is made of Jindal stainless steel pipe of 2 inches, and the rotation of that is transferred to this larger sprocket wheel through a smaller sprocket wheel and a chain mechanism, so as to reduce the speed and increase the torque, because I need more torque to operate the pump. Okay. So as it rotates, this sprocket wheel also rotates, and on the sprocket wheel is a wobble mechanism. This wobble mechanism will make this rod go up and down as it rotates, as you can see here. But otherwise this length of the rod, and this is the piston, and as you can move the piston towards backside, I can get more sweeping distance here for the operating the pump. But as the sweeping distance increases, then the power will be reduced, so therefore I have to hit a balance between these two. I think presently I have kept at 6 inches of freedom for the pump. Now coming to the pump itself. Basically the piston itself is made of 2 inches PVC pipe, and this is provided some freedom to operate because of because the piston is mechanically driving it. I use a regular 2 inches UPVC pipe and pipe outlet. I make my own pump and my own piston. After a lot of research, what I found out is that the sealing ring for the piston can be made out of inert materials, which is, in this case, it's a yoga mat. So any discarded yoga mat can be used because it's very inert in any temperature or water. Prolonged soaking of water, it doesn't deform itself. So I initially started using O-ring and other conventional material, but then what I found out is that in wind, when it comes to wind energy, we cannot waste any energy aspect of that, and we should get a pakka sealing because the pump has to give high pressure to push the water, the column of water which will be there under the bore as well as up to the overhead tank. So therefore I need high pressure as well as proper sealing. So therefore I am using this little soft material and creating the required pressure. Now let's see the pump itself. This is basically the pump. Just this will go into the bore well, and the length is the breadth of this is kept very minimum so that it can be inserted into the existing bore well along with the jet pump. When the pump is operating, when it is pulled, when the air is pulled out of this, the water will come inside and get locked here, and when it is pushed, this will lock and this will open, and then water will go into that. So initially the air will operate, and later on, because these two pipes go up to the ground level, the water will get filled up eventually, and once the water gets filled up, the water will act like a sealing. The other aspect is the foundation itself. This mechanism allows this entire tower to be tilted, and this is a stand through which it can support itself, so that after tilting, the farmer can assemble the leaves and then make it straight, and this will be for foundation. So once the concrete foundation is made in the field, then this tower can be attached to that. As you can see, I have also innovated on the stand aspect also. The foundation itself need not be on a concrete. So I am actually now working on a rented apartment. So I don't have a luxury to do any fittings on the floor. So this entire windmill is now standing on its own, and this particular design I have made for myself to support the tower. So any amount of wind it can withstand and protect the tower from falling down.